The next topic we're getting into is soil. Soil is such an important resource, and we're going to talk about the reason why it's so important and why it gets its own section of the geology unit as we talk about soil. Soil is its own ecosystem. It's its own support life system. It is almost like compared to another planet of our solar system. In fact, the world that's in the soil that's beneath our feet, it's amazing just how much life it can support. And without soil, we would not be here. Life on this planet would not exist without soil. So that's why it gets its own special mention in this geology unit. So in order to explain it, we have to define what soil is. So the upper layer of the earth, which is exposed to constant weathering and erosion, or at least weathering, is taking large chunks of rock and breaking them down into smaller and smaller pieces. Well, not only that, is in that layer at the surface, like I was saying, there's a whole ecosystem of life that life actually supports a lot of life that's in it. So all the plants, all the trees, grass, any other type of life. You have animals that live in the soil as well. So soil has a very complex definition. It's the upper layer of the earth consisting of a mixture of clay and rock sediments. That's due to weathering. However, that's just explaining dirt. However, if I add the decayed organic matter material, then that is considered soil's definition. Soil is not soil without life being involved in it. So the first question in the soil research is, how is soil formed? I kind of started to talk about the process of formation of soil. So let me go to the next picture to kind of give you that idea. This picture is a really good overview, time-lapse overview, picture-wise, of the formation of soil. Think of the earth as we talked about the beginning of the earth, the structure of the earth being all solid rock, and then weathering would take place at the surface. Well, that solid rock starts to get broken down. Like we talked about sedimentary rocks. You get a big chunk of rock and it turns into smaller pieces of rock. So all soil starts as a large piece of bedrock. Now this is early in the history, when soil was first discovered or created on the earth, or this goes back as much as recently with those volcanic eruptions in Hawaii, on the Big Island for days on end. All that lava is turning into igneous rock. All that igneous rock at some point is going to go through the soil formation process. So this doesn't just happen millions of years ago. It also can happen present day. It starts with large pieces of bedrock with no life in it whatsoever. That large piece of bedrock, that big chunk of rock, is going to start getting broken down by weathering. So in the second picture, you start to see the bigger chunks of rock turn to smaller chunks of rock. Organic matter is going to start adding itself to that rock. Now, life will always start small. So certain types of things will start in the rocks are like mosses, which have very thin root systems. They don't have to dig down deep in the ground. Lichens, which is a fungus, is also going to be some of the similar life that you're going to find. When that organic matter dies, it adds nutrients to this rock, and then other life will start to feed off the decayed organic matter. We're going to call that humus. So you see in the picture there, the organic matter starts to thicken the soil and actually break those pieces of rock into even smaller pieces of rock. So layers will start to form. They call them horizons. Will start to form within the rock layers. So the third picture on this screen shows you a thickening layer over time, and then bigger root systems, plants will grow like wallflowers, and then eventually grasses roots can start to take. Eventually, the soil thickens and thickens and thickens so that those plants with bigger root systems can actually thrive and survive in this soil. And then you get trees which have even larger root systems, and they can dig deeper and deeper into the soil. So as you see in the picture, it starts with a picture of bedrock. Then you start to see the bedrock break it up into smaller pieces, even smaller pieces, but life starts to grow and get bigger and bigger and bigger. So on the next couple of slides, I just kind of talk about, how the bedrock turns into smaller and smaller pieces, and then I get into the life aspect of it. Two types of way rocks can go from a large chunk of rock to smaller pieces of rock is physical weathering and chemical weathering. Physical weathering is those made by physical means. So wind, water, sunlight, gravity, ice, people. These are all ways that rocks can be broken from a big chunk to a small chunk at the surface. Remember, this is weathering, not erosion. Erosion means that the particles are then transported somewhere else. Weathering is just a breakdown in that area. Chemical weathering is also a breakdown of minerals and rocks, but putting them through a chemical reaction that actually kind of weakens the rock. So for example, iron. Iron is a mineral and it's found in a lot of rocks. When water and air hit iron though, it chemically changes the iron and turns into iron oxide, which is rust. You see that as a red sections. If you leave, let's say, a bike and you leave it outside and all you see these red flecks all over it, those are flecks of rust because the iron that's making up that bike is starting to rust away because of the exposure. Its exposure to the air and water. That is a chemical reaction, and that chemical weathering process causes that to break down and become weaker. Well, soil can have the same effect. It can be broken down through physical means and through chemical means. And again, it's not soil until life is added to it. So you really only need to kind of focus on the life aspect of it. So I kind of walk you through the process here of life starting on the earth. It starts small, lichens, mosses, bacteria, fungi, protozoa. All of these are going to make decayed organic matter, which is called humus. Not the same hummus as people eat, because that's ground up chickpeas that the hummus people eat. This type of humus is just organic matter that gives nutrients to other organic matters in the soil. From there, other types of life start to inhabit the soil, making the soil thicker, digging down deeper, making those rock particles even smaller. You get earthworms, you get moles, and even some larger animals will make habitats of the ground. And again, the plants were making those longer root systems. They'll make habitats of those things too. So soil is not soil unless life is added to it. So the next question gets into what are the levels of soil. So the other way we call levels of soil is horizons. So that's one of your key terms. Horizons just means levels of soil. The fact that over time, that huge chunk of rock breaks to smaller pieces and creates different sections of soil. Even though we're talking about 9 or 10 feet of soil at most in some of these areas, they still can break up into separate sections. So we're going to start from top to bottom. The top layer of soil, the soil that you interact with, unless you go digging into the ground, is either ground level soil or it's topsoil. When you leave your house or you walk outside, you walk in your yard, you're interacting with ground level soil. Okay? However, if you were to go to a farm or go to a field where they grow crops and that's topsoil. That type of soil is much thicker and filled with so many more nutrients so it can allow those things to grow. The ground level soil you interact with around your house on a regular basis only has like grass and trees and bushes, those types of root systems, so the soil is not as thick as topsoil will be. These two layers of soil are the top layer. We call them horizon A. You can also call them horizon O because this is where the majority of life is found, in that top layer of soil. As you go deeper in the layers of soil, less and less life or organic matter is available or even present in those bottom layers. So the top layer has got not only the smallest rock particles, it's also got the most life. The next layer underneath that is subsoil, and subsoil is horizon B, which is underneath the layer A. You'll get some root systems that will stretch down to the subsoil. You'll get some bigger animals like moles and gophers might dig down into the subsoil if they're able to do so. Other than that, you really don't have a whole lot of organic matter that makes up subsoil. The rock particles start to get larger and larger. Take it like this, and I don't think you've ever dug a hole in your yard, but if you ever did, it's so easy to dig those first couple of layers, and then once you get the subsoil, now you're starting to interact with bigger chunks of rock. If you keep digging, you're eventually going to get to solid rock. That's bedrock. So you'll go through all the different layers if you try to dig in your yard. The next horizon down, which is horizon C, is called weathered parent material. The rocks it's just big chunks of rocks. There's no organic matter in this section. It's just big chunks of rock that have broken off from the bedrock itself. So this is horizon C. There's no life and just big chunks of rocks. To the point where then you get to bedrock, which is the bottom layer. It is solid rock. If you're going to dig into the bedrock, you really need to have some kind of machinery or tools that will really allow you to break up the chunks of rock that are there. So those are the horizons of soil. Here is a soil profile picture. Now, you as an activity are going to be creating your own soil profile picture. So this is a little more detailed. It breaks up the organic matters, the O layers. So these are the organic layers. That's what the O is standing for. Horizon A is just below the O. Usually I say A and O are the same layer. They're all part of the top layer of soil. Then you get the horizon B layers, down here, and the transitions to C as well. Here's your weathered parent material, no organic matter in there, and then you've got your bedrock, which is that last layer. Okay, so that's a soil profile. What are the different particles that make up soil? So in order to explain this, I'm going to compare the particles of soil as if it's a story. And the one story I always remember is Goldilocks and the Three Bears. If you're not familiar with that story, Goldilocks goes to this house, sees there's porridge on the table, tries one, says this one's too hot, tries another one, says this one's too cold, and then finds baby bears, and that is the just right one. Goes to try the beds. This bed is too hard. This bed is too soft. This one is just right. So why am I talking about Goldilocks and the Three Bears when I'm talking about soil particles? Because these particles make up soil, and there's restrictions to these particles of the perfect type of soil for growing a lot of different types of crops. So we're not looking for ones that are, we're looking for the soil that is just right. So at the end of this particle discussion, I'll explain that. So for example, sand. Sand is a soil particle. It can be found in soil. Now, if you have a soil made completely of sand, you're going to have what's called coarse soil, and it's too coarse, which means there's a lot of space between the particles of sand. So what does that mean for water? Water will not be held in sandy soil. Water will pass right through it. So plants that need water to be held within the soil can't survive in this type of soil because there's no water that's being held. If you've ever gone to the beach and you try to build a sandcastle and you put sand in a bucket and then you put water in the bucket, water passes completely down to the bottom of the bucket. Okay, so the upper layers, even though they look wet, they're not holding any water at all. So sand is too coarse, not good enough to be a soil that supports a lot of life. Now, there is life that sandy soil will support, like desert life, cacti, and those they've adapted to those rough conditions. Silt is too light. Silt is a type of soil you find near riverbanks, creeks, streams, all that area. So they can hold a lot of water. However, the soils themselves are those particles themselves are very light, which means they can erode away very easily. On a riverbank, when the current of a river meets the silt on the side of the river, then what happens is the river will pick up the silt and carry it downriver and deposit somewhere in a delta or in another area. So silt soil that we want to grow a lot of things can't be too much silt because that'll be too light. It will erode away too quickly and you won't have soil for growing things. On the top here, clay. Clay is another particle you find in soil, but clay is too fine, which means there's not a lot of space from particle to particle of clay. Now think of our class. If you ever used clay in our class, you moisten it, you keep it wet just so that you can form it to whatever you want it to be. Once clay dries though, it is impermeable, which means water can't pass through it. That's why you make a lot of bowls and mugs and cups of clay, because water can't pass through it. If you've got soil that's made entirely of clay, there's going to be no root systems of plants, there's going to be no water that can get to those roots. So it'll be basically barren land. It will be no plant life growth at all in that point. So clay is too fine. So the soil that we're looking for that is the just right, like I said, my idea of Goldilocks and the Three Bears is called loam soil or loamy soil. And all that it means is it's a blend of clay and sand and silt. If you've got a nice blend of those things, then you have a good, a just right soil to grow majority of crops. Many different types of crops can actually grow there. The plant roots can get in there. It will hold a certain amount of water. Won't hold too much, and you'll get a decent crop if you have a decent loamier soil. Even with grass or trees or bushes, they really thrive on loam soil. Okay, next are a couple words for your key terms for your glossary, and it talks about soil and its ability to either hold water or let water pass. The first word is called porosity. Porosity. Think of the word porosity. Think of the holes on your skin that let sweat pass through or let hair follicles pass through. Those are holes on your skin. Well, soil, because of particle space, has holes as well. Those holes are the porosity of the soil. So sand has a high porosity. There's so many other holes that allow water to pass through. Now, the problem with sand, though, is water just passes through. It doesn't hold any water. The porosity is more about the holding of water. So silt has a very high porosity, it will hold a lot of water. Clay has a very low porosity, it can't hold any water. So that's what porosity is referred to, is how much water the soil can hold. The other word I have here is called permeability. If water can pass through rocks and soil and all this, it means the soil level is permeable. If it cannot pass, like through clay, clay is impermeable, with an I-M before the word. Impermeable means water can't pass through. Permeable means water can pass through. So with soil, you're looking for the permeability of soil, which means how much water does it let pass through. Sand has a very high permeability. Clay has a very low permeability because water can't pass through it. It's impermeable. So when we talk about rock layers, especially if you have a house that lives on a well and you get water from inside the ground brought up to the surface, you're looking for rock layers that will let water get down there. Once it rains, water soaks into the ground through groundwater. It's trying to pass into those aquifers. It's got to go through the permeable layers to get down there. If you've got soil that is impermeable, like clay, no water is going to get to those aquifers that are deep in the ground. And that's a source of fresh water. That's what people that have wells need, that fresh water, because they don't have any other water systems of water. So what type of soil do we have in Boyertown? This was just kind of some simple question. I found a website that kind of talked about it. And it talked about the bedrock that makes up the soil. So different rocks we've talked about in sedimentary rocks, especially like sandstone and shale and siltstone. Those are all sedimentary types of rocks. They make up our bedrock. So I show you in the map here a picture of where Boyertown is, just about where Boyertown is. And I show you the types of rocks that make up our soil. Shale is a big one. So if you dig anywhere around here 2 feet down, you're going to bump into shale. Red shale, to be specific. We live on sloping land because we live in elevated areas. Our erosion potential is moderate to high because of the sloping land, so which means the soil we have can erode away very easily with a lot of rainfall. That's why a lot of the farms in Gilbertsville, a lot of them are not active anymore because the topsoil that did make up those farms, a lot of that topsoil has eroded away and it kind of killed off the farm and the farmland. Water holding capacity is moderate, which means we can grow a lot of crops that thrive off a moderate holding capacity. The corn, the wheat, lettuce, a lot of the vegetables you find in the grocery store can be grown in this area because we have good water holding capacity. So to conclude, I do ask the question, what's the difference between soil and dirt? Dirt's the stuff you find on your fingernails, while soil is the stuff you find on your feet. Soil is an ecosystem. Soil is its own world. Soil is not soil without life being added to it. If you're just talking about rock sediments, broken up piece of sediment, that is just dirt. That is not soil. Okay? Soil is not soil until life is added to it. So this is just a brief overview of what we talked about with soil so that you could fill in your research pages in your journal. So if there's anything you don't understand, please ask, please email me and ask, or review this video.